So you are given something like this on the EDTA titration. Say weigh 1 gram of sample A, which is zinc sulfate heptahydrate, into 100 ml volumetric flask. Dissolve in 20 ml of distilled water and then make up to 100 mark. Now, if you look at this very well, you agree with me that based on what you've learned so far, it means 1 gram is actually present in 100 ml, because you actually put this 1 gram, they say put it in 100 ml volumetric flask, dissolve in 20 ml of distilled water. Forget about this one. The total amount of water at the end of the day is 100 ml, which is the 100 ml mark. So we are going to come here and say this is much. So you are going to come here and say 1 gram of zinc sulfate heptahydrate is present in 100 ml mark. Now come back. At the end of the day, say transfer an aliquot of 20 ml into a conical flask and add a thin drop of mordant black. Now you must be very careful. I think they did not use this entire 20 ml. Is that okay? They did not use the entire 20 ml, because if you look at the factor given here, they gave you 0.1. Is that okay? So transfer an aliquot of 20 ml into a conical flask and add 18 drops of mordant black. Now what does that mean? It means from this 100 ml, look at it, you have this into a conical flask. So you have 1 gram here, and then you have 100 ml of water. Now they say from this one, what you are going to do is take some part of it, transfer them into a conical flask. Is that okay? Which is something like this. So you are going to transfer 20 ml from here into here. Now it means if 1 gram of zinc sulfate heptahydrate is equals to 100 ml of water, therefore 20 ml, we want to calculate the mass of standard sample. That means the mass of the sample they say you should what? You should actually assay. 20 ml will be equals to X. So cross multiply, and then this is supposed to give us, this multiplied by this is supposed to give us 100x is equals to 20 times 1. So divide both sides by 100. When this cancel this, our x is 0.2 gram. Is that okay? Which is 0.20 grams. So it means the weight of standard sample, the weight of the sample you are taking into experiment, weight of standard sample is what? Is 0.2 gram. Is that fine? It is 0.2 gram. Now, what is the formula for calculating factor? We are told that our factor formula is equals to weight of standard sample, right, all over milli equivalent times titer value. However, if you look at the formula that you are giving factor. This is one correction that somebody pointed me to. Is 0.0100 divided by milli equivalent times titer value. That was this thing we are giving. What is it called? The milli equivalent, the formula for factor you should use to calculate. Now, however, the formula that was actually given to the one that you should use, the weight of standard sample is 0.2 gram, because from the instruction they say take 20 ml, and 20 ml will contain 0.2 grams. So weight of standard sample is supposed to be 0.2 gram as opposed to 0.10. However, this was what we are given. Now, it may be that they actually divided this 20 ml into two. Sometimes when they say instructions from manual, they usually change them. So instead of pipetting 20 ml, they pipetted 10 ml each for each of the assay. That is why it gave us 0.10 all over milli equivalent. But in a case where this factor formula was not given, you use your normal 0.2 gram all over milli equivalent times titer value. But since they already gave you the formula you should use, don't bother going to use this one again. Use the formula. But if the formula is not given, it will now be weight of standard sample over milli equivalent times titer value. Weight of standard sample now will be what? 0.2. But since they already gave you 0.1, they already know what they measured there that made them to give you what? 0.1 gram as opposed to what? 0.2 gram. All right, so that is that. Now let us calculate the milli equivalent. They say 285.5 gram of zinc sulfate heptahydrate is equals to 1000 ml of this sodium editate. Is that okay? So what we are going to do is so what we are going to do now is to write this 285, I think so, 285.5 gram of zinc sulfate heptahydrate, 0.5 gram of zinc sulfate heptahydrate is present. They already gave you the relationship in 1000 ml 1 molar sodium editate. So it says present in 1000 ml 1 molar sodium editate. All right, exactly. Now, my dear students, what do you do at this point? You want to look for the milli equivalent. Now, before you look for the milli equivalent, there are things you must put in mind. The molar mass, the molarity rather, the concentration of EDTA used. The concentration of EDTA used here is 0.05 molar. Is that okay? 0.05 molar. So you want to know the amount of zinc sulfate that reacted with 1 ml of 0.05 molar EDTA. EDTA is the sodium editate here. This is what you use. Concentration of this that reacted with 1 ml of 0. So you convert this 1 molar to 0.5 molar EDTA. So first of all, to convert, told you need to look for the 0.05. To get 0.05, what do we do? First of all, we divide by 2 here. If you divide by 2, that is going to give us, if you divide by 2, that will give us 285.5 divided by 2, which is 142.75 gram. Don't need to write off, just put zinc sulfate heptahydrate to give us 1000 ml 0.5 molar, because when you divide this, sodium editate. But what you are looking for is 0.05, so you are going to divide here by what? 10, and you have to divide here by 10 too, so that at the end of the day, this is going to, when this cancels this, it's going to give us 14.275 gram zinc sulfate heptahydrate, right? Is going to give us 1000 ml 0.05 molar sodium editate. Is that okay? Now divide both sides by 1000 mil. Divide both sides by 1000 mil. When this cancel this, because you're looking for 1 mil, all right, and this cancel this, that's going to give us 0.0 divided by 1000, 0.01427 zinc sulfate heptahydrate. Is that okay? Reacting with 1 mil 0.05 sodium editate. So this is your milli equivalent. Is that okay? It means 0.014275 gram of zinc sulfate reacts with 1 mil of this concentration of sodium editate. Now let's come back time to calculate our factor. Now what was the formula for factor? Say factor weight. They already gave you this one, so you don't need to put this one. This is 0.00 divided by milli equivalent times titer value. Now in the question, the titer value was given, so let me write it as TV titer value. Titer value was given as 16.8 mil. So you come here and say titer value is 16.8 mil. All right, so that at the end of the day, your factor now for this one will be 0.10 divided by, what's your milli equivalent? 0.014275 times the titer value 16.8 mil. So what will be our factor? Factor will be equal to 0.1 divided by 0.014275 times 16.8 mil. Factor will be equals to 0.147. Okay, 0.417. Sorry, not 14. 0.417. Factor of EDTA. All right. So this is the factor of what? EDTA. Now, is this factor now that you are now going to use to calculate for the other question? Please check if there are any error. I didn't have the time to cross-check this before solving. Say sample B is a solution of magnesium sulfate heptahydrate. It is the heptahydrate that was actually used. Are you getting it? Transfer in aliquot of 10 ml into a conical flask and dilute to 50 ml in distilled water. Now, transfer in aliquot of 10 ml or an aliquot of 10 ml. That means out of this one, are you getting it? Transfer 10 ml into a conical flask and dilute it with distilled water. Add 10 ml of ammonia, buffer, and 1 ml of modal black 2 indicator and titrate with 0.05 EDTA until the wine color changes to blue. Repeat the titration. Now, when you are giving something like this, it's very, very easy for you to solve. Are you getting it? But you have to be very, very careful. All right. So in this case now, what do you think we can actually do? It's very, very easy. It's very, very easy. Now we already giving the what is it called? The milli equivalent. However, if the milli equivalent is not given to you, you also know how to calculate it. In a very sharp way, we can say magnesium sulfate from the equation of reaction. Of course, you should have known the equation of reaction. I always tell you to put that at the back of your mind. We give us 1000 mil, 1 mole of magnesium sulfate, right? We give 1000 mil, 0.05 molar EDTA. Sorry, 1000 mil, 1 molar EDTA. Now, at this point in time, what do? To calculate your milli equivalent, you must convert this to 0.05 molar EDTA because this was what was reacted. So you divide here by 20 sharp. You don't need to first. You have to calculate the mass of this. The mass of this is going to give us 246 grams. So we say 246 grams of magnesium sulfate heptahydrate will give us 1000 mil. I'm just showing you in case it was not given to you, but they already gave it to you. So to calculate, to convert 1 to 0.05, divide by 20, right? So you divide here by 20 also. When this divide 20, what is that going to give to you? Going to give you 246 divided by 20, 12.3, to give us 1000 mil, 0.05 molar EDTA. Now, at the end of the day, divide by 1000. Divide by 1000. When this cancel this, it's going to give us 0.00123. Are you getting it now? We react with what? 1 mil of that. That is the value they got here, 0.01234, 0.0123. Is that okay? So those of you that we're getting another thing is because in that question they use magnesium sulfate. In your manual they use only dried magnesium sulfate and not the heptahydrate. So you should know the difference between magnesium sulfate and the other. If they say this thing was dried, it means you are no longer going to be using the word heptahydrate, because when you dry it, the water of crystallization will evaporate. Is that okay? But in case it is not dried, you actually use the heptahydrate as part of it. But the milli equivalent was or is already given to you, so you don't need to really bother yourself too much about that. Is that okay? Now we'll now come back here and calculate. The question now says calculate the amount of magnesium sulfate present in aliquot of 10 mil. What is the formula for calculating calculated mass? Now when they say present in 10 mil, what they are just asking you is how much of magnesium sulfate did you actually assay? Because they say solution B is a solution of sample B is a solution of magnesium sulfate heptahydrate. Say transfer an aliquot of 10 mil. What they are asking you is how much of magnesium sulfate is in 10 mil that you actually pipetted. How much of magnesium sulfate is in this 10 mil that you pipetted? And this 10 mil is what you used to carry out your what? Experiment. Is that okay? So it means, forget about this 50 mil that they say you should dilute it to. The 50 mil is just, the dilution is just there to just make the volume up to 50. The initial amount of the stock you pipetted is 10 mil. So they're asking you how much of magnesium sulfate is present in this 10 mil. What they are just asking is the calculated weight of magnesium. The calculated weight of magnesium. And what is the formula for calculating calculated weight of magnesium in 10 mil? The 10 mil there, I will explain again. This 10 mil here is what you pipetted, what you carry out the experiment. When they say how much is present in the 10 mil, they ask you the calculated weight. Because it's from this 10 mil you actually get your titer value and the rest, the calculated weight. So you now say calculated weight, or say amount of magnesium sulfate in 10 mil will be equals to milli equivalent times titer value times the factor. Now you know your milli equivalent, you know your factor, but you don't know your titer value. Now from this experiment, let us assume, it's an assumption, that does not mean that's what you are going to get. Let's assume your titer value, the one you got from the experiment, is 8 mil. We are just assuming because you are going to titrate. Is that okay? What you are going to do is you titrate with EDTA. Is that okay? So EDTA will be on your, what is it called, on your burette. EDTA is what will be on your burette. Is that fine? Why magnesium sulfate is what will be on your conical flask. So what you're actually looking for at the titer value after running it twice is the mass of the volume of EDTA used. However, they may just give you alternative to practical and say the volume of EDTA used is so. You just put it. Is that okay? The value of EDTA may be given to you. If it's alternative to practical, they may just say the volume of EDTA, value of EDTA is so. So you just write out that value. Now, at the end of the day, what are we going to get? So amount of magnesium in 10 mil. Milli equivalent is, what is the milli equivalent they gave to you? 0.01. So this is titer value. The milli equivalent is 0.01234. So this is 0.01234 gram. Is that okay? So amount of magnesium sulfate in 10 mil will be your milli equivalent 0.01234 times titer value. Titer value is 8 mil times your factor. What was the factor of EDTA we calculated? 0.417. So we say multiply by 0.417. Is that okay? So that at the end of the day, what you are going to get will be equal to give us 0.01234 times 8 times 0.417. All right, which is equals to 0.04116 gram. So this is the amount in that 10 mil. Is that okay? This is the amount of EDTA in that, amount of magnesium sulfate in the 10 mil of the amount of magnesium sulfate present in the 10 mil of the aliquot. The amount of magnesium sulfate itself present in the 10 mil of that aliquot solution. Now, of that solution, what quantity of magnesium sulfate heptahydrate in 100 mil solution? That is 1 liter. So it's very easy. You are now going to say 10 mil contain what? I'm doing number 2ii now, 2bii. 10 mil contain this amount, 0.04116 gram. Then 1000 mil would be equals to x, and then at the end of the day, this will be equals to 10x is 1000 mil times 0.04116. Divide both sides by 10. So when this cancel this, x would be, when this cancel this, 100 times that. So you have 100 times 0.04116, which is 4 point. All right, 4.116 gram. So this is the amount that is present in 1000 milliliter. Now they now say if the amount dissolved in 1000 milliliter is 12 gram, what is the percentage purity? This is the percentage purity. Now percentage purity, weight of pure sample, sometimes some persons say actual weight all over expected weight, which is also weight of impure sample, which is also expected weight, times 100%. Now, how much was actually there? They told you that the weight of the pure sample is the weight we got from our calculation here. Is that okay? In this case now, weight of pure sample is 4 point, because that is what is present in 1000 mil. It is very easy. The assay will tell you the exact amount that is present. So first of all, the first one gave you in 10 mil you get 0.04116. In 1000 mil you get 4.116. Now, that is the weight of pure sample that is present in 1000 mil. Now, they now told you that initially the amount that was actually dissolved in 1000 mil is 12 gram. Is that okay? Is that many gram? 12 grams. So impure, it means that 12 gram there are impurities actually present. But when you now assay and purify, you only got 4.116. So you are now going to say weight of pure 4.116 divided by weight of impure 12 times 100%. Are you getting it now? Now, at the end of the day, you have 4.116 divided by 12 times 100%, which is 34.3%. Is that okay? Weight by weight. All right, so that is the weight. Now, I think that is all. The next thing is, what is EDTA? What is it used for? EDTA, I think that was the question there. Let me see. You have what is the role of Mont Blanc? It's an indicator. What is the title for this experiment? 1 and B. 1A and B. Now, 1A is standardization of EDTA using zinc sulfate heptahydrate. Is that okay? Standardization of EDTA using zinc sulfate heptahydrate. That is the title of the first one. That is the title of the experiment, not complexometric titration. Standardization of EDTA using zinc sulfate heptahydrate. Then B is called assay of magnesium sulfate heptahydrate using EDTA. Told you the two experiments, that is their title, not complexometric titration. If you just write complexometric titration, you'll be wrong, because complexometric titration are much. The first one is standardization. The first experiment, standardization of EDTA using zinc sulfate. You should write it in full, heptahydrate. While the second one is assay of magnesium sulfate heptahydrate using EDTA. Then in bracket, you can now put in this one complexometric. Titration. Do you understand now? That's what you are supposed to do for all this. Exactly. Then the other one there, what is the role of Mont Blanc as an indicator? What is the pharmaceutical application of EDTA and sample B? Now, EDTA is ethylene tetraacetate. EDTA is a complexometric agent. It is used in chelation. Are you getting it? And it's also used to increase the aqueous solubility of drugs. Is that okay? It's used to increase or improve the aqueous solubility of drugs, and it's used as a chelating agent that is given in case of antidote in poisoning and for chelation of specific metal ions. You can write that. Then magnesium sulfate. What's the role of magnesium sulfate? Magnesium sulfate also is used in the treatment and prevention of seizures and so on and so forth. It was also used as an anticonvulsant. That is prevention of seizures. Are you getting it now? So that is that.